Hello, we are the team number 13 of the Scada and Industrial Controllers course, made up of Victor Caicedo, Jair Castañeda, and Duan Sandoval. For this first challenge, we received a request from our client, in this case our professor, to automate a box conveyor controller by a PLC. The software used for this task is Studio 5000, developed by ROCKWELL Automation and Logix 5002 for the emulation of the PLC used. RS-Links was also used for the communication of an OPC server locally, which allow us to communicate with a digital twin of the buffer station via factory I/O software. As you can see at this moment, the logic used is made in ladder language, where 5 steps were used. In the first and second step, we can observe the interclocking behavior for the start and stop circuit of the conveyor belt. We also see a variable that corresponds to the emergency stop that we will see later. After this, we have a counter that counts the number of boxes that pass through the first conveyor belt, and that when it counts the number of boxes predefined by the user, it activates a stop blade and turns off conveyor belt number 1. Then, when the box reaches the end of the second conveyor line, a sensor is activated and resets the counter and the first conveyor. But to observe the behavior described a little better, let's move on the digital twin so that the conveyor belt begins to work. We press the start button. We can observe how the boxes begin to be transported through the first belt. Then, when the first sensor that performs the count counts the indicated number of boxes, stops the first belt, avoiding their accumulation in front of the stop blade. Meanwhile, the second belt continues its route, carrying out the transport of the boxes in an orderly manner. When it arrives at the end of the conveyor belt, the boxes activates a sensor that restarts the counting process and activates the first conveyor belt. To understand a little better how the logic works in ladder, let's see how our digital twin and Studio 5000 works at the same time, where when pressing the start button on our digital twin, Studio 5000 recognizes a signal which starts the transport process. While the boxes circulate, the first sensor is activated and in turn activates the count process, as we can see in the Studio 5000 counter. When it reaches to count, it stops the KN1 output, which refers to the first conveyor belt. Then the logic waits for the activation of the second sensor, which will activate the transport processes again. Let's see how our reset button works a bit, which take all the processes of our logic to a start where the counter is at 0 and the conveyors are off. Let's take a look at how full logic works alongside our digital twin. Finally, we can observe the complete operation of the control panel, where some bad manipulations of the function are simulated, and how the emergency button works by disabling all other functions. In this way, until this button is deactivated, the mechanism of the machine will not work, preserving the safety of the living beings and that are around, and also the integrity of the machine. In conclusion, learning to program PLCs and implement this logic in digital twins opens the possibility to learn about new technologies and to quickly and easily implement these situations that occur daily in much larger productions and industrial lines. For the professional life of an electrical, electronic, mechatronic, or mechanical engineer becomes an added value that you don't have when the university life ends. Therefore, it opens a niche of job possibilities that perhaps we don't contemplate very frequently.